Today we're going to look at how to convert rectangular equations to cylindrical ones. Here are some equations you'll need. X equals r cosine theta. Y equals r sine theta. And z equals z. So the basic process is that we're going to take equations that are in terms of x, y, and z, and we're going to put them in terms of r, theta, and z. So let's look at a basic question you might get on this. Z equals 17. Now, as you can see here, there's no x coordinate to convert, and there's no y coordinate to convert either. And we know that z equals z, so all we have to do is just present this as the answer itself. There's nothing to change it to, and it's the same in both rectangular and cylindrical equations, so the answer is z equals 17. Now let's look at another problem. So what we want to do here is we want to simplify this as much as possible. And we'll use algebra. Let's get everything on one side. So we have, well actually let's start over here. Let's simplify this part in the parentheses. So I'll just bring this part down. Leave this for now. And I'll distribute that 1/2. I'll multiply that into the parentheses. So 1/2 of 2x is just 2x. 1/2 of 2y, that's just going to be y. And now we're going to bring all the variables onto the same side. Well, let's just go ahead and move them all to the left. So here, we'll start with this. I'll add 2z to both sides. Now I'll subtract 2x from both sides. And now I'll subtract y from both sides. So we're left with z equals 9. Now, that's the simplified version of this. So as we saw in the last problem, once you get to this part where z equals 9, that's the answer itself. There's really nothing you can do. And it goes back to how z equals z, whereas x equals r cosine theta, and y equals r sine theta. There's no x or y coordinate to convert. So z equals 9 is your answer. So let's look at another problem now. So this looks very complex, but what we're going to do is we're going to use algebra to simplify it as much as possible. Now notice everything is being multiplied by 1/9. That's the same as dividing everything by 9. So that's our starting point. We're going to get rid of that fraction by multiplying everything by 9. So when you do that over here, the 9 times 1/9, that's just 1. So 1 times z to the third, it's just going to be z to the third. Using the same process, this becomes 512, and over here, this part goes away, and we're left with the part in the brackets. Now, since there's nothing out front here in front of the brackets anymore, we can actually get rid of the brackets altogether. So let's see what else we can do. Let's go ahead and simplify this part here. We're going to multiply 4/3 into 27. So that's the same as saying, that's the same as having the 27 be over the 3. So that's going to be a 9. And then 4 times 9, that's going to be 36. So this part over here is just going to turn into 36x. Now here, the cube root of 46,656 is also 36. And the cube root of x cubed, that's just going to be x. So let's bring down this part. Now as you can see, the 36x cancels out with the negative 36x. So that part goes away altogether. So we're almost at the point where this is as simplified as possible. What we're going to do now is we're going to finish this by taking the cube root of both parts here, both sides. Cube root of z to the third is c, and the cube root of 512 is 8. So we're at that point again where we have z equals 8. And with these equations, x equals r cosine theta, y equals r sine theta, and z equals z, we see once again that there's nothing further we can do, and that z equals 8 is our answer here. Let's continue with another problem now. So in this equation, before we look at anything else, we're just going to try to simplify it as much as possible. Let's start over here, a to the 1/3. That's the same as the cube root of 8. And the cube root of 8 is 2. So let's just bring down everything else now. Now, everything here in this equation can be divided by 2. So that's what we're going to do. Now here, there's nothing further we can simplify, so let's get the equations. And this time I'm going to introduce a fourth one. Now the fact is, you could go through a long process of using these two equations and substituting them here. But like I said, that's a very long process, and you have a shortcut one right here. So we're just going to use this part, where we have an x squared plus y squared equals r squared. We're going to switch this out with the r squared. So let's just do that down here. Z plus 4 equals r squared, because r squared equals x squared plus y squared. So now, let's just go ahead and subtract the 4 from both sides. And that's your equation here. That's as far as you can go. So this is going to be your answer. Let's go ahead and do one more problem now. Let's go ahead and use algebra to simplify everything as much as possible. Now the smallest fraction out of all of these is 1/4. So we're going to get rid of all the fractions by multiplying everything by 4. When you do that here, the fraction cancels out and you have y squared. This becomes negative 2z. This becomes negative x squared, and this becomes negative z squared. And now let's bring everything over to the same side of the equation. And we're just going to rearrange this so that x squared is in front, and then y squared plus z squared minus 2z. There's nothing else that can be simplified algebraically, not for our purposes anyway. So let's go ahead and write out the equations from before. So you have x equals r cosine theta y equals r sine theta, z equals z, and r squared equals x squared plus y squared. Now out of these, we can once again switch out the x squared plus y squared with this part right here. So let's go ahead and do that down here. So you have r squared plus z squared minus 2z equals 0. So there are no x or y coordinates left to convert. So let's go ahead and look at this part right here. And this was a z squared. Right here, we can go ahead and complete the square. So let's go ahead and do that. So r squared plus z squared minus 2z. Now half of that is just going to be negative 1. But when you square that, you get positive 1. So that's what we're going to add here. And what you add on the left side of the equation, you have to add to the right. So now we have r squared plus z squared minus 2z plus 1 equals 1. Right now, let's go ahead and factor this out. This becomes z minus 1 squared. And now let's bring down everything else from before. So you've got your r squared plus z minus 1 parentheses squared, and then your 1. And now that's as far as you can go. So that's going to be your final answer here. If you like this video, go ahead and hit the like button and subscribe for more videos.